So for today, we're going to be looking at questions 31 through 38. Okay, so we call this bivariate because it has two variables, right? X's and Y's. But to begin with, let's take a look. I'm going to be looking at questions 31 and 32. We're just scatter plots. Scatter basically means points, right? Just put them in there. I can come out with information, right? I could ask you guys for one variable here. Let's say at the bottom, not our case, but let's say at the bottom, I ask you guys for your height. So I'm just going to say your height, right? I'm going to compare a variable. You know, we all have different heights. So I could come over and ask about the height in relationship to, let's say, the weight. I could have some information about height. I could have some information about weight. We match our height with our weight, and I'm going to come out with some points. Or if I ask people that. So that's the thing that we can come out with, two variables. So again, bivariate, two variables, height and weight in this case. And we're going to be looking at points. So here in question number 31, I came with some points. Now, not necessarily height and weight, any other things. I have points there. And what I'm asking here is state if there appears to be a positive correlation, negative correlation, or no correlation. What I mean with that is a negative or a positive correlation is, do I look like the information is going up? I always read from left to right. It doesn't have to go up on a line. It could go up on a curve, right? Do I look like the points are going up? There will be some points that are off the line, but does it look like it is represented as if it is going up? That's a positive correlation. A negative correlation will mean, does it look like the information is going down? It could be a line. It could be a graph, like there's a curve. Does it look like it's going down? And no correlation is, yeah, I cannot tell. Is it going up or is it going down? So looking at question number 31. Here, it looks like these points are represented by this curve. It looks like it's going down, right? These points are going down. The information is going down. So this will be a negative correlation. Negative correlation. Now, question number 32. Does it look like it's going up? Does it look like it's going down? This one, some people might say, if I look at this point, it is going down. But if I'm looking at this point, it looks like it's going up. Now, if I'm trying to draw a line that represents all of them, I cannot tell. I cannot tell if it's going down, if it's going up, like what is going on. So in this case, I call this no correlation. Now, this idea of correlation is going to be used a lot once we move into statistics. In our stats class, they look at this type of idea a lot. Now, let's take a look at two more examples of these, 33 and 34. 33, it seems like I can represent a curve. I can represent this point by this. It looks like my information is going down. So I'm going to call this negative correlation. And question number 34, it looks like it's going up. So I'm going to call this positive correlation. Question number 35 as well. Here we have some information, right? The height and weight of several adults were recorded. I have the height of certain people. I have the information here. I have the weight of certain people. So I have a table with information. Not only that, but I also plot the points in. If you notice this point, that is this point. The height of it is 4.65 and the weight is 100. So notice how each of my points is each of this information on the table, right? Height with the corresponding weight. Each of these gives me a point on the graph at the side. So I see the table, I see the graph, I can see the positive correlation. So what that means is that the more height a person has, the more weight it has. There will be some points that are off my line, and it's fine. Not only that, but it was discovered that this can be modeled by an equation here. Okay, so now this equation, you notice how it has a y and an x. Where usually when we graph, we're known that the x-axis is the one that goes horizontal. So matter of fact, let me put an x here. And the y is the axis that goes vertical. So when it comes to x, I'm talking about height, right? When I use that equation. Anything that is about height, I'm gonna use the x value. And then the y value, it's corresponding to pounds, or weight in this case. Now looking at here, question A, using this model, I'm gonna use the equation. In reality, I'm gonna use the equation. When I say equation, I mean y equals 51x minus 143. Using this model, what will be the weight? So it seems like I don't know the weight of someone who is 4.9 feet tall. First thing I gotta ask myself is, this 4.9, is this the x or the y value? Height, here it says feet tall. Height is the x value. So let me put an x there. So I'm gonna say I'm using the equation, but instead of an x, I'm gonna write a 4.9. Okay, so what do I mean with that? Let me zoom in here. I know my equation was y equals 51x minus 143. So again, let me just write that thing down. Y equals 51x minus 143. Right, I just copied the equation. Let me zoom out a little so you guys can see where I got the equation from the top. And then the number that I have, the 4.9, I'm going to replace that for x. So let me rewrite this as y equals 51 times 4.9 minus 143. Right. I replace the number given for one of my letters, either x or y. In this case, I replaced it for x because it was height. And solve for the missing variable. So in this case, solve for y. If I have y as a y, solve for y. If I have x, the letter that I have is still x, then in that case, solve for x. Now I know I'm gonna have y equals, I have to work the side. I know I have to multiply it before I subtract. Now 51 times 4.9 is 249.9 minus 143 equals 106.9. Now, when I read the instructions here, it says round your answer to the nearest tenth. Okay, TH means basically my answer will be decimals. Now, tenth, think of the number 10. How many zeros are there? 1 0, right? 10 has a 1 0. So when I say tenth, I mean 1 decimal place. Sometimes I'm going to use the number hundredth. Hundredth, it's going to be 2 decimal places, right? It sounds like the number 100. It's a 1 with 2 zeros. So if I ever use the number thousandth, you can guess, 3 decimal places. All right, I'm done with part A. Let me take a look at part B. According to the model, what will be the weight of someone who is 7 feet tall? I'm going to use the same equation. Y equals 51x minus 143. And I'm going to replace. Now, one value, 7. I'm giving a 7. Got to ask myself, is that height or weight? 7 feet tall. Well, that's height. And remember, height is the x value. So let me rewrite this as y equals 51 times 7 minus 143. I know 51 times 7 is 357 minus 143. I get that y is equal to 214. I don't have a decimal. My instruction said round your answer to the nearest tenth. Okay, so if I have decimal, just one decimal place, I don't have any, so I'm good. Now here, what height corresponds to a weight that is of 130 pounds? So remember, our equation was y equals 51x minus 143. And we said that anything that was weight was the x value. I mean, anything that was height was the x value. Anything that was weight was the y value. Now the number given, 130 pounds, that's my y value. So let me rewrite this as 130 is equal to 51x minus 143. So I'm solving for the letter that's still left. In this case, I'm solving for x. All right, I want 51x to be by itself, so the negative 143, I'm going to cancel it out. I'm going to move it to the other side as a plus 143. Remember, we got to switch the sign. So that gives me that 273 is equal to 51x. I'm solving for x, remember? And then let me divide both sides by 51 because I want x by itself. So that gives me that x is equal to 273 divided by 51. I use a calculator and wow, I get a big decimal. I get 5.35294 and some more numbers. All right. Here in the instructions, it says round your answer to the nearest hundredth. Hundredth means 2 decimal places. However, I do take a look at the third decimal number. If the third decimal number is big enough, it will push the previous number up. So it will push the 5 up. So if the 2 was big enough, it will push the 5 to a 6. And what I mean big enough is 5 or more. In this case, it is not, right? 2 is too small. So I'm just going to ignore the numbers after that. My answer will be 5.35. Again, if the 2 was big enough, push the 5 to 5.36. Okay. Let's take a look at another example. Again, I'm working up into question number 38 on our notes. Let's take a look at question number 36. Now, something about temperature and electricity. I'm given some points here, right? The information from the table, each of these represents a point on my line. I see is a positive correlation. So the higher the temperature, the higher the electricity that I use, which makes sense. And I'm also given an equation. Now, the x value is this information at the bottom, temperature. The x value is temperature. The y value is electricity. So let's take a look. Using the model, how much electricity will be consumed if the average daily temperature was 66? Round your answer to the nearest kilowatt hour. All right, so it seems like I'm gonna round it to the nearest whole number. Now my equation here, the equation I'm gonna be using, let me take a look, is y equals 0.441x plus 7.44. So let me rewrite this as y equals, because the number given is the x, right? In this case, temperature, we said x. So let me rewrite this as y equals 0.441 times 66 plus 7.44. Again, I'm just using the equation given, and I replace my value of x. I know I have to do multiplication first, right? I'm looking at this multiplication, 0.441 times 66. I use my calculator that says 29.106. So I do the multiplication plus 7.44. I get that y is equal to, I get 36.5. Now the instructions, it said round your answer to the nearest kilowatt hour. So nearest whole number. All right. I take a look at my first decimal place. It is big enough. So the 5 is going to push the 6 over. So my answer will be 37. Right, I'm going to the nearest whole number. Okay, let's take a look at question number B. According to the model, how much electricity will be consumed if the average daily temperature was 97 degrees Fahrenheit? Round your answer to the nearest kilowatt hour. Again, we got to ask ourselves, temperature is at the X or the Y value. In this case, the X. So let me rewrite my equation. Y equals 0.441 times 97 plus 7.44. Got to multiply first, right? 0.441 times 97. That gives me 42.777 plus 7.44. It gives me that y is equal to, according to my calculator, I get 71.5. Well, 71.5. The 0.5, it's big enough, so my answer will be 72. Right? The 5 is big enough, so it pushes the previous number up. Instead of 71, I say 72. Big enough, again, is 5 or more. And lastly, question number C, it says, what temperature will it need to reach in order for 39 kilowatt per hour to be consumed? Round your answer to the nearest degree. So in this case, let me rewrite my equation. 39 kilowatts, that's my y value. So let me rewrite this as 39. It's equal to 0.441x plus 7.44. To get the x by itself, let me move the 7.44 as a minus 7.44. So that gives me 31.56. It's equal to 0.441x. Let me divide both sides by the 0.441. Right, the number in front of the x. 31.56 divided by 0.441. I'm using a calculator here, and I get 71.5. Remember, my answer is the nearest whole number. So I'll always take a look at one decimal place after. The 5 is big enough. So my answer here will be 72. Oh, actually, coming back to B, I just saw one mistake here on B. My answer for B, actually, it's 50. Because I came out with 50.2. When I multiply this out, some of you might be like, hey, yeah, I got 50.2. So my answer for B was 50. My bad. Okay. Now let's take a look at 37. With the help of scientists, farmers in Cameroon have been able to produce more and more grain per hectare in each year. Here are the crop yields for several years. So, okay, so the information here, something about a year, what happened in 1961, and how much grain did they produce. So I have some information here. Each of these things represents a point on my graph, and it gives me an equation. I'm going to use that equation. Now, first of all, got to see the X and the Y value. The X is the horizontal. So anything that talks about year, that's the X value. Anything talks about the production, that is the Y value. So let's take a look. Remember, I'm going to use the equation given. According to the model, what was the crop yield in 1980? So the number given is year. So let me rewrite this as Y equals, because remember the year represents the X value. So 20.4 times 1980 minus 39,200. 20.4 times 1980 is 40,392 minus 39,200. It gives me that Y is equal to 1,192. I'm supposed to round this to the nearest whole number. I don't have a decimal, so 1,192. Example B, assuming that this trend continues, what crop yield is predicted for the year 2028? Okay, the year 2028. So again, that's the X value. So let me use the equation and I'm gonna go Y equals 20.4 times 2028 minus 39,200. Multiply first. 20.4 times 2028, that gives me 41,371.2 minus 39,200. I get that Y is equal to 2,171.2. Now in the instructions, it says round your answer to the nearest whole number. Okay, my first decimal place is too small, right? 4 or less is small, so I'm just going to ignore it. My answer would be 2,171. Now this model indicates, I'm looking at question C or part C. This model indicates that a crop yield of 1,100. Now this number, gotta ask myself, is this the Y or the X? Production. So that's the Y value. Was achieved in what year, right? It's asking what year. So it's asking for X. All right, so the way I'm gonna do this, let me write this as 1,100. It's equal to 20.4x minus 39,200. To have the X by itself, this minus, let me move it over as a plus 39,200. So I get 40,300 it's equal to 20.4x. Let me divide both sides by 20.4. This gives me 1,975.4. My instruction says round your answer to the nearest year, so the nearest whole number. My decimal place is a 4, which is too small, right? 4 or less is small. So my answer will be 1,975. If my first decimal place was 5 or more, I would have said my answer is 1,976. All right, my last example for today, let's take a look at question number 38. The hurricane hunters took the following measurements from a hurricane over several days as it developed. Something about air pressure and wind speed, right? The wind speed we measured in knots. That's the measurement we use for the speed. And when it comes to air pressure, KPA, that's basically air pressure in millibars. So each of these things, each of this information gave us a point on the graph. All right, again, there's my second point and so on. I came out with a formula, came out with an equation. Now, some of you guys might be like, how do they come up with that equation? We're going to learn that a little bit more in stats. If not, you can also plot it in Excel. You guys are familiar with Excel? Plot those points, come out with the graph, and the graph will actually give you the equation. Now, here's the equation. We're going to use this equation. Now, the X value is the horizontal value. This information at the bottom. The X value is the air pressure, and it comes in millibars. The Y value is the wind speed. We measured wind speed in knots. So here, using this model, what will be the wind speed of a hurricane with an air pressure of 392? Okay, the air pressure. Remember we said the air pressure was the Y value. No, the X value. So I'm going to use the equation, but instead of X, I'm going to use 932. All right, so having that said, let me write this as Y equals negative 1.03. And instead of X, I'm going to use 932 plus 1070. So I'm using the equation that we have above. Multiply first, and then add 1070. I'm going to end up getting that Y equals 110.04. Let me read the instructions here. It says, round your answer to the nearest knot. So the nearest whole number. Okay. My first decimal place is small, right? It's a 0. So I'm going to ignore everything after that. My answer is 110. Second question. According to the model, hurricane with an air pressure of 890. Right? Is that number we got to think? Is that the X value, the Y value? Air pressure, we said it was the X value. And then it's asking what wind speed. Okay. So let me use my formula. Y equals negative 1.03. Instead of X, I'm going to use 890 plus 1070. Right, do the multiplication first. Negative 1.03 times 890 plus 1070. And I'm going to get that Y equals 153.3. Here it says round your answer to the nearest knot, the nearest whole number. My first decimal place is too small, like 4 or less is small. So my answer will be 153. Let me come up with some space down here. Let me erase this information too. I'm going to come up with a little bit of space to work. All right, looking at example C now. The model indicates that a wind speed of 62 knots. The wind speed, is that the X or the Y value? In this case, is the Y value. So let me rewrite this as 62 equals negative 1.03 times X plus 1070. Let me subtract the 1070. So that gives me that negative 1008 is equal to negative 1.03x. To get the x by itself, let me divide both sides by negative 1.03. Good thing on the left, negative divided by negative is positive. 1008 divided by 1.03, I get 978.6. My instruction here is rounded to the nearest millibar. Remember, this measurement is millibar. I need to round it to the nearest whole number. My first decimal number is big enough, right? 5 or more is big enough. So this 6 pushes the previous number up. So my answer will be 979. Okay, let me zoom out. You can take a look.